Hello and welcome to this last video for this chapter, where we're gonna talk about few things that has not been mentioned during this chapter, uh, introduction chapter. Well, I still want to say that for an introduction, it's quite going deep and showing like really nice functions of the language and. So they just want to finish this chapter by showing few things that have not been showed yet. So I didn't have time to really look what is going to talk about, but from what I can see right now is the control flow. So about control flow, they already show us if, else, for, but they didn't show us the switch statements, which can be really useful. So let me show you what it is. So from the school where I studied when I was still a student, so now 4 years ago, switch statement was not allowed to be used. We were just allowed to use if, else, and while, and nothing else. But I have already seen that on some other language. So the switch statement is quite popular and you can find it in many languages. So just let me show you what it looks like. Package main, func main, blah blah blah. Okay, and then what a switch statement is. So switch take an instruction or a value of something. So for example, here we take coin flip in this example. So it's a function, and we will actually switch on the return value of coin flip. So coin flip can return either head, so case head, either what is the other name? Tails, and default is something else. So ft println land on the landed on the edge. So if it's head, then heads plus plus. If it's tail, then tails plus plus. Just implementation. So how it works? So you got a switch statement. It's gonna switch on the return value of coin flip. So coin flip can return heads, tails, or something else. Looks like so. So maybe edge anyway. So what it does, it check, and the statement is going from the top to the bottom. So if it's found if it's the case is right, this one, for example, case heads, then it will stop here and it will not try the other one. So coin flip return heads, then we increment heads plus plus. Case the case that switch return tails, then we increment tails. But we also have the default. Default is for other value. So if the statement is not either one of the case we have, then it's going to be the default one. So it depends what you are doing, but it's really important to always have like a default most of the time to make sure that you handle all the case possible and avoid to get a bug in your code. So you have those kind of switch. So what they said about that is that the result of calling coin flip is compared to the value of each case. Cases are evaluated from top to the bottom, so the first matching one is executed. The optional default case matches if none of those cases does. Right, that's what I said. And then there is what we call the tagless statement, tagless switch, I think. Let me check, I think it's written, yeah, tagless switch, it's the name. So you can have a switch without nothing written here, and actually it means how they call that, signum x int, and then we return int. So we're gonna check. So when you write switch without any instruction or any tag, it means that it's like writing switch true. So you will switch until you find something true. So here, for example, switch nothing, then case x is greater than 0. Then if it's this, if it's the case, wait, oh, if it's the case, then return 1 plus 1, default return 0, and case x is smaller than 0, then return -1. So that's a tag, what is called a tagless switch. So there is nothing written, and we are gonna just go case by case until we find one which is true. So does x is greater than 0? No. Does x is less than 0? No. So it's default and it's true. Return 0. That's it for the switch, and there is nothing more to say about it. The following is about name types. Okay. It's to show that you can create a type for struct type point. So you create a type, like for example, int is a type, string is a type. So here we're creating the type point, and it's gonna be a structure, and this structure gonna take, for example, x and y int, and then you can use it in your code. So you just need to package main func main, all right. And then here you can just declare, for example, p as a point type, and then you can use it just under. So for example, p.x equal 1, p.y equal 2, and then you have a point with these two values. It can make the code really cleaner. For example, the point one is a really good example. And I think you can have this kind of example. So I already show you some structure when we were reading the source code of some other library in the previous video. So we didn't go too much into the details, but that's what it does. You can use it as a new type and use it in your code, and it can help to make it really cleaner. What does it say? A type declaration make it possible to give a name to an existing type, since struct types are often long. They are nearly always named. A familiar example is the definition of a point type for a 2D graphic system. So yeah, the one I just showed you right now. Then they also talk about the pointers. So in Golang you have pointers. Go provide pointers. That is values that contain the address of a variable. In some language, notably C, pointers are relatively unconstrained. So in some other languages can be called references or something like that. But you will see that later, and if you are really interested, you should go on Google and read what is a pointer. But it's only storing an address of a value actually in the memory. So what you do, you will see often, for example, we call that éperluette in French, but I don't know in English. So the end, it means that you of a variable. So for example, dot, let's say con. So you are sending the address where is stored the pointers, and to give the value of con, so you put a star before and then con, and then that's the value of con. That's how it works. So what does it say about that? Pointer are explicitly visible. The AND operator yields the address of a variable, and the star operator retrieves the variable that the pointer refers to. But there is no pointer arithmetic. We will explain pointer in another section. I can actually wait for this, or I can also, if you want, you can just ask, and I'm going to make another video where I explain with also some drawing to draft and explain better. But pointers in C language is quite common and super useful. In Golang, I don't know why for the moment I didn't find any case where I really needed it, and most of the time it looks like more easy than in C language. I didn't have any problem with Golang as I could have get with C language when I was learning. But maybe that's also because now I know what a pointer is and I don't have any problem with it anymore. So they talked about methods and interfaces. So I don't know what it is in Golang yet. A method is a function associated with a name type. Go is unusual in that method may be attached to almost any name type. Methods are covered in a chapter 6, so I think we're gonna wait for the chapter 6 to know what it is, and interfaces and abstract type that let us treat different concrete types in the same way based on what method they are. Not how they are represented or implemented. Interface as a subject of the chapter 7. So same thing, I think we're gonna have to wait for the chapter 7 to understand what it is exactly. But from what I've heard, interfaces is a bit like a type where you can put whatever you want inside, and then it will work. That's what people tend to say. That interface is a solution of the problem, but generally create more problem that solve the main issue. So packages, Go comes with an extensive standard library of useful package. So we already used some of them. So for example, image color, net HTTP, etc., etc. And the Go community has created and shared many more. That's really true. There is a lot of package out there. Throughout the book, we will point out a couple of dozen of the most important standard package, but there are many more we don't have the space to mention, and we cannot provide anything remotely like a complete reference for any package. So that's definitely true. I think a book cannot handle that because every day a new package is created out there. You can check on GitHub, there is plenty of them, and some of them are even better than others. But the community is quite young. I mean, it's not like a whole old language. So when you choose a library, it's still good to make sure you are taking one with a lot of stars on GitHub, and that there is still some commits. So it means that it's still maintained and someone is improving it every day. So better to when you have to create a real big project to make sure you are taking uh, the right one and will allow you to use your code for a while. So before you embark of any new program, it's a good idea to see if package already exists that might help you to get your job done more easy. So that's actually I cannot disagree with that, and that's probably how I learned to code. Um, and we often say don't make the wheel again, but I really enjoy going like in lower level and doing my best to create things by myself first before using a library. So some of them can be a waste of time. So for example, if tomorrow I have to create um, a tool that is working, for example, with Slack, I will not make my own API package for handling the API connection with Slack. I will probably use one which has already showcased that it works fine because dealing with API, I will not learn so much, and it will be a waste of time. But for example, sometimes uh, I don't have an example here, but to work on a string, for example, I will probably try myself to work with the bytes instead of going directly with the strings package. And it also helps to make code slower because when you import a whole package for just one thing, sometimes it can make your code bigger. Probably not slower because the code are really good and makes the best of it, but yeah, definitely your code or your binary at the end will be bigger. They show another function that we didn't have the chance to use the last time. So it's in terminal, and that's nice. Let's discover it together. I increase the size for you to have a better view. So they show the Go doc. Go. I'm gonna go read the doc, the help first. So Go doc show documentation for package or symbol. So let's try. It was HTTP listen and serve, for example, and then you can have the doc instead of googling it. I think I will be always faster Google things, but if you are working offline, that you can use this. It can be helpful. So package HTTP import net HTTP func listen and serve added it. So it takes as argument a string and a handler, and it returns an error listen and serve. So that's exactly what is written actually when I was doing this project and I was going over it. So if I go over listen and serve, we can read exactly the same thing. So it's gonna probably read it in the doc. So let's check. I'm curious actually. Where is the doc? So yeah, it's probably taking not here. So I don't know where they store it. It's actually really interesting because if tomorrow you have to create a package, um, mm, go to definition now. I'm looking for the path. Maybe here. Okay, copy path. Let's go and see. So not here. HTTP. cd-doc maybe? No. Ah, curious. So that's something we should take a look. Because if tomorrow you have to create a package that's going to be shared, maybe you will have to create also this kind of documentation that would be useful. I'm wondering if it's actually not this. It's just taking the command just above on the code. Listen and serve. Where was it? So yeah, I think that's actually this, and they also print the first line. I guess that's how the documentation is handled. Anyway, let's see that one another day. And then the last thing is a sentence written. So comments. We have already mentioned documentation comments at the beginning of a program or package. It's also a good style to write and comment before the declaration of each function to specify its behavior. These conventions are important because they are used by tools like Godot. Oh, but that's exactly what we were looking for. So yeah, they use the comments that we write on top of the function to create the Go documentation of your package. And Godot to locate and display documentation. For comments that span multiple lines and or appear within an expression, there is also the, okay. So they show that if you have a multi-line comment, you can use this and then put everything inside, blah, blah, blah. It's a command, it's a command, it's a command, it's a command. Or you can either just use the slash, double slash, and this is a one-line comment. All right, just let's cancel everything here and close it. And that's it for this chapter. Now we're gonna go through a next chapter, which is called program structure. It's gonna be, I think it's gonna be really repetitive. It's gonna talk a lot about, for example, type with few example. I don't see so much exercise on this chapter, but well, I think it's important for the knowledge to go through this. For example, there is plenty of plenty, maybe not, but there is some types which is related to int, and maybe we will have to make the difference, and it could help to skip to save some memory or something. I don't have any idea, but for example, we have this int 8, int 16, int 32, int 64, and uint 8, etc. So maybe go through this could be useful, and also to help us to choose the perfect type when we are working. And as always, I think when you choose you choose the right variable type for your function, it also showcases a lot that you understand what you are going to put inside and understand what you're doing. So, well, that's what we're gonna learn in the next chapter. Thank you for watching so far the first chapter, and if you have any comments or advice to give me, please just write down what you have in your mind, and I will read it and comment. Thank you very much for watching. Have a good day.